I'm going to go over these problems. I'm going to hit on like significant figures, the use of them in calculations, talk a little bit about metric system, dimensional analysis, and then density calculations. And that's really the most important topics in chapter 2. And it's, I mean, it's about the only ones. Anyway, I am assuming that you have watched the videos, worked some problems, you're somewhat familiar with the material, and I'll just highlight different bits and pieces as I work through these problems. And one of the most important, relevant topics that we run across in chemistry is this issue of significant figures. And really, the significant figures, part of it is just a set of rules that you learn. And I'll go over the rules as I work through a few of these problems. But more importantly, the sig figs tells us something about the accuracy of the measurement. Now, like for example, this number here for A, if we put some kind of unit on that, like grams for a mass unit, 58.31, what that tells us is, in the context of accuracy, that whatever measuring device that we use to measure that mass, the value is good down to the hundredths position. So it's not the best balance, like our balances in the analytical balances in the laboratory can go down to 2 more significant figures. They're much more accurate, about 2 orders of magnitude. So significant figures and accuracy of measurements are really woven together in a way. Again, the bottom line for us is really, it just comes down to learning a set of rules. Like for example, if we want to determine the number of sig figs in some of these values, well, the sort of low-hanging fruit, if you will, is this idea that, well, if you have non-zero numbers like we have right there, they're all significant. Usually that rule doesn't bother students all that much. Like for example, when a number is in scientific notation, this upper part here, however many numbers are listed there, that's the number of significant figures. And notice what I'm doing. If you see a numerical value with a circle around it, and I'm specifically referring to the number of sig figs there. By the way, if there was a 0 sitting there in that scientific notation, then that would also be significant. So again, scientific notation has a lot of benefits, cleans up numbers a lot of times, but it also gets across significant figures without, in some ways, worrying about rules. Whatever numbers are there are significant to the measurement. Now, the parts that become troublesome are the zeros here. Like for example, this number has a lot going on with it. Now, obviously, 2 and 5 are non-zero. They are significant. The zeros in front, the zeros in back, well, it just depends. And again, there's a set of rules that the video that are posted on Moodle has gone over. Basically, any 0 that you have in front of the measurement are not going to be significant. And then if it's something less than 1, one of these small numbers, then that 0 is going to be significant. So typically we say if a decimal is showing and the 0 is on the right-hand side of the numerical value or the non-zero numbers, then it is significant. Like for example, down here, we also have zeros that are the right-hand side of the expression, but notice there's no decimal in this number. And so what we say is that, well, really, it's just those 2 digits that are significant. So there's only 2 sig figs there. And oftentimes, instead of writing it this way, you would write it in scientific notation form. Something like this, where you get rid of the uncertainty about the zeros there. And then just as a little, side note, if it had been written like that with the decimal shown, then we have, in this case, 4 significant figures. Again, sig figs, in some ways just boil down to a set of rules that we learn, but ultimately it's dealing with the accuracy of the measurement. Okay, so rounding issues, a combination of sig figs and rounding issues. Like for example, for your typical calculator, when you do a plug and chug, a lot of times it fills the screen up, okay? And if you're actually using a set of data to do some calculation, like on the lab this week, you have to decide how many sig figs do I want to keep? What reflects the accuracy of the measurements that I was just using? And I actually sent out an email yesterday evening about that as well. Like for example, let's say, well, this one, well, let's do this one first. Why not? So you got all these numbers on the calculator, and just hypothetical scenario, the data that you're using had 3 significant figures in it. That's a lot of the reasons why you're just rounding to 3 sig figs if you're doing like multiplication and division, which you usually are, okay? The addition subtraction rules that you saw in the video, they rarely pop up. We'll apply in an example coming up, but they rarely show up in a practical application. Okay, so what do you do with this? Okay, so I know I need to round off to, or keep 3 sig figs. So I'm gonna go in. What you do is you're really looking for your first 3 significant figures to keep, okay? Like in this example, I mean, again, there's no 0, so there's no ambiguity in terms of significant. I mean, all of these are non-zero. I guess the significant figures is instructed in the problem. Anyway, you pick out the first 3, and here we go. We have this 9 sitting there. The rounding rules that we saw on the videos is that if the next digit down is 5 or more, you're going to round up. And so this one would be rounded up to 1.35 would be the 3 significant figures rounded properly. Now, this number here actually it shares some similarities in terms of the 9 is going to be the digit that's going to tell us how to round. But the first part, like picking out your sig figs, it's a little weird because you got all these zeros here. Again, you just have to remember any 0 on the left-hand side will not be significant to the measurement. So that means that we're picking out 1, 2, 3. We want to keep those digits, and we're going to drop those, rounding appropriately. And just like before, this is 5 or greater. And that means we're going to round this the second number 4 up by 1. And I'm going to write this out a couple different ways. There's 4 zeros there. 1, 2, 3, 4, and then 3, 4, 5. Now, that is a properly notated number, 3 sig figs, rounded properly, check. It's done if you want to stop there. But I'll just go ahead and just make a little comment here. And changing pen color may not be the most convenient thing. Usually when there's zeros sitting there that are not significant, we try to clean them up using scientific notation. 1, 2, 3, 4, 5. If I move that decimal place, again, 1, 2, 3, 4, 5 positions, then what I can do is use an exponent on 10 to indicate where that decimal is. 3.45 times 10 to the minus 5. Again, cleans it up, gets rid of the non-significant zeros there. Now, in a practical sense, like I said, either way is fine. But imagine that there were 20 zeros sitting here. 1, that's cumbersome to work with, and 2, your typical calculator can't handle that number. It's going to convert it into scientific notation just because it just gets rid of all that bulk that's really not needed. We sometimes call these zeros placeholders, meaning it tells us what place we need to go to, hundredths place, thousandth place, or I guess in this case, 100,000th place. I think I'm getting that right. 10, yeah. It tells us what place we have to go to find the first significant figure, okay? Second one here, round each number to 3 significant figures, kind of the same thing. And well, let me do one where we're not rounding up there. So there's our 3 sig figs, And now the next digit down is a 4. So if the next digit down is between 0 and 4, then you just drop this portion of the expression and you don't round anything up. Okay, you just keep those 3 sig figs. So 6, 5. Oh, sorry. That is 65.7. No rounding on that one. Application of. So, right, there's this aspect of learning the sig figs and, just how to use them, round them, that kind of thing. But there's also the issue of application of the sig figs in terms of a calculation. And I just want to do this top one here. And the reason why I want to do this one is because multiplication and division are really the two operations that you will do, you'll do almost all the time. Okay, addition and subtraction really doesn't show up. It does some places, but really not that much. Okay, so what are the rules? And the rules are down here. Basically what it's saying is that when I do this calculation, actually let's just, what is this number? This is your modern calculator is just going to spit out a bunch of digits on you. And yeah, so I'm going to go ahead and convert it into scientific notation. Okay, so you've done this math. You see all this in your calculator. Again, if this was real data like volume, mass data, temperature data that you collected in the laboratory, well, each of one of these were being collected by different type of instruments with different types of accuracy. A number like this implies a high degree of accuracy, much more than any of the instruments that you use. So that use of significant figures tries to reflect, it's like sometimes I refer to as an approximation of the error that's associated with a given problem. Okay, how do we apply it? Well, we go through each one of these numbers and we identify how many significant figures are in each number. I'm going to do this kind of quickly. So what I'm underlying are the significant figures. I have 4 sig figs there. These zeros are not significant. There's only 1 sitting there. That's going to be important. And then there's 2 in that number. The rule is, no matter how accurate all your other numbers are, it's the one that's the fewest number of sig figs that's going to dictate how you round this thing off. So even though your calculator is very generous in its math, you can't use any of this. Your final answer needs to reflect something about the accuracy of your worst measurement over here. And so you would report this, like if it was on your report sheet or something, you'd actually report it like this. Okay. Now, the addition subtraction rule is a little different, and I'm just going to sort of shoehorn it in here. It also gives me an opportunity to talk about the orders of operation. Is that the one I'm doing? Yep, that's the one. Okay, so when you're working a problem like this, if you see parentheses or brackets or something like that, usually parentheses for us, it's telling you that you need to perform this mathematical operation first and then do the rest of the problem. And so I'm just going to sort of take it out in steps here. I'm just going to rewrite this part. I'm going to do this math, and I'm going to use all the information that my calculator is going to give to me, okay? So 330.42 would be the value there. And then I'm going to do this math, okay? So again, first thing, order of operation. And notice that I'm doing all of the math first, and this is very typical for any type of calculation. And I'm going to write out everything my calculator has given me here. Now, obviously, on the report sheet, you would not need to write all of it out. You would just apply your sig fig rules and write down what the appropriate numbers are. Okay, so now I've done the math. Great, it's not too bad. Now the application of sig figs. And basically, since you have subtraction and multiplication here, you're using two different rules and you're using them in sequence, right? So what I mean by that, and maybe the blue can stand out a little bit better. Like for example, the rule for your, if it's addition or subtraction, the rule states that the fewest number of decimal places would dictate how you would round this thing off. So if I applied that rule to this number, it means that I would have just, written out the 0.4 and dropped the 2. Now, I kept the 2 in when I did the calculations, but now I am applying the rule in terms of determining the significant figure treatment of the problem. Like for example, okay, so I know that with this digit, that 4 is significant, the 2 is not. Well, useful to know, because then when I think about my multiplication operation, what's the rule there? Well, the rule there says that, well, actually it's the fewest number of sig figs in your values that you're multiplying is going to dictate how you round off. So in this case, right, there's 4 reliable significant figures in this total number. There are 4 here. And so therefore, I am going to round off to the first 4 significant figures that I see there. Round off, right? What does that number look like? Well, it's 5 or greater. And so that means I'm going to round this thing up 1 digit. So the correct number would be 1288. Now, these examples of significant figures, they're practice for learning sig figs, right? Now, when we do real calculations like kilometers to miles or density calculations or all the other calculations we're going to do for this class, we'll apply all these rules that we're learning in this chapter. Okay, so this is all just sort of, practice in a vacuum. It's not, there's no context to any of this. But, and I'll come back to this as needed, right? This is more, typical information here.